Yes, guys, let me continue from question number 6. Now, this is the question we are doing. Now, in this case, as I have told you, this is delta theta here. Okay, angle between POQ angle is delta theta, while this angle is pi by 4, as I just told you, that theta equal to minus pi by 4 to plus pi by 4. The reason is if I put r square equal to 0, r equal to 0 here, then cos 2 theta equal to 0. When cos 2 theta equal to 0, that means cos 2 theta equal to cos pi by 2, or 2 theta equal to plus minus pi 2 here, theta equal to plus minus. This I have explained number of times. So these two loops are lying between minus pi by 4 to plus pi by 4. Again, this is also lying between this tangent line. Okay, so there are two loops here. This is second tangent line and this is other one. Okay, so these angles are again 3 pi by 4 to minus 3 pi by 4. This is 3 pi by 4 to theta equal to, and this is theta equal to minus 3 pi by 4. Okay, so in this way we have taken these two loops. Now we are calculating the volume generated by this one loop, and twice of that will give us the total volume. So this is the question we are just doing here. Okay, now we know that what is the volume generated by an arc, okay, about the initial line. This is about the initial line here. Now in this case we can just argue that why this is the tangent line, not the initial line, but I have taken the angle theta plus pi by 4. It is still representing the initial line type. Okay, so because of that, this formula we have taken. In place of theta angle, we have taken theta plus pi by 4. Now, if I substitute the value of RQ, this is in case about the initial line in case of polar coordinates. If the volume is generated about the initial line after revolution of the solid or the revolution of the surface about the initial line, then this is pi r 2 by 3 pi RQ into sine theta d theta. Okay, this we have explained in case of previous lecture series. And when this solid is revolve about the line at theta equal to pi by 2, in that situation it is 2 by 3 pi into RQ into cos theta d theta. These are the two formulae which we use occasionally. Okay, but in this case we are using, because this is about initial. This is an initial line, but this initial line is still, because theta plus pi by 4 if we have added. Okay, then this angle is still representing initial line. So the same formula we will use, but only angle is changed here. Now let me open this. Now this is twice here. I'm just telling you that twice into volume of the solid generated by one loop. Okay, this is the value here. Volume generated by one loop is given by this. Here limits are minus pi by 4 to plus pi by 4. This is minus pi by 4 here to plus pi by 4. That is the point. Okay, so now let us check, because this is the tangent. About this line we are revolving this whole loop here. Because of that, this is minus pi by 4 to plus pi by 4 limits here. Now this is 4. Let me further solve it. Sorry, 4 by 3. 2 to the 4 here. Sorry. This 2 to the 4 pi by 3. Within bracket it is minus pi by 4 to pi by 4. Here RQ is this value, but R, if I just calculate, then this is equal to R equal to A cos 2 theta, A into cos 2 theta whole power 1 upon 2. R is equal to, therefore RQ is equal to, here it is RQ, therefore RQ is equal to AQ into cos 2 theta whole power 3 by 2. That is value of RQ from the equation number 1. This is from first R value of R. So this is, let me write here, AQ, within bracket it is cos 2 theta whole power 3 by 2 into, now sine theta plus pi by 4. Let me open this whole. This is this value. Now let me solve it above. Now here it is theta equal to minus pi by 4. Now let me solve it above. Okay, here. So that now let me drop half of this. Okay, the figure now is understood. Now let me take this value further. So this is equal to volume we are calculating. Volume of the cardioid. Is it cardioid? Question number 6 here. It is the solid generated by revolving the it is lemniscate. Volume of the lemniscate. Volume of the solid generated by the lemniscate. This is volume of the solid generated by the lemniscate. This is the lemniscate here. Lemniscate is equal to this value I am writing here. Now again, if I write minus pi by 4 2, let me still write it minus pi by 4 2 plus pi by 4, no problem at all. This is 4 pi by 3 minus pi by 4 2 plus pi by 4. Here it is. AQ, let me take outside. This is AQ. Only cos 2 theta whole power 3 by 2. Within bracket, if I open sin theta, A plus B formula. What is sin A plus B? We know that it is sin theta into cos pi by 4 plus sin, this is now cos theta into sin pi by 4. This is whole value into d theta. Okay, just I have opened sin A plus B formula. Sin A into cos B plus cos A sin B. This is sin A cos B plus cos A sin B. Now let me further solve it. It will give us, this is 4 pi by 3 AQ, limits now minus pi by 4 to plus pi by 4. Okay, now this is cos, let me multiply them. Now this is cos pi 4 is 1 upon root 2, sin pi 4 is 1 upon root 2. Let me take 1 upon root 2 outside. This is 1 upon root 2. Within bracket it is now cos 2 theta whole power 3 by 2 into sin theta, first one, into d theta. This is, let me open this in two terms. Second is again cos 2 theta whole power 3 by 2 into this sum of integration, let me write it separately, minus pi by 4 to plus pi by 4, theta equal to, okay, this is cos 2 theta whole power 3 by 2 into sin, into this cos, this is cos theta into d theta. Now this value equal to 0. Why? But let me write here, this whole is d theta. Okay, these two terms are there, 1 upon root 2 multiplied, so let me take 1 upon root 2 outside. So it will be 4 pi AQ upon 3 root 2. Okay, this is minus pi by 4 to plus pi by 4. Now this value equal to 0. Why this is 0? Only this will left over. Why? But let me further write cos 2 theta whole power 3 by 2 into sin theta d theta. Same thing I am writing again, plus 0 to this minus pi by 4 to plus pi by 4. This is cos 2 theta whole power 3 by 2. This is cos theta into d theta. But minus pi by 4 to plus pi by 4 into cos 2 theta whole power 3 by 2 into sin theta d theta equal to 0. Why? As it is an odd function. At cos 2 theta whole power 3 by 2 into sin theta. Okay, sign of integration, let me write here. Minus pi by 4 to plus pi by 4 into d theta is an odd function. Is an odd function. Okay, in case of odd function it becomes negative. If I take that negative term, this whole equal to minus sign this whole value, that can be taken to left hand side, then sum of these two is twice of that equal to 0, total value equal to 0. This comes out to be 0. This is a property of definite integrals. Okay, this value comes to be 0. Because of that, this term is 0, only this value is left over. Now let me write it here. Therefore, let me write shortcut. V is equal to volume is equal to 4. Now this root 2, if I multiply into root 2 upon root 2, this is 2 to the 4. It will be 2 root 2 in the numerator. It is 2 root 2 into pi aq upon 3 in the denominator. Now this value, this one is only left over. Now this is minus pi by 4 to plus pi by 4. I can write it as 0 to pi by 4, twice of this. Okay, that's all right. But this now left over only cos 2 theta whole power 3 by 2 into cos theta d theta. Now let me further solve it. That will give us the final answer. The question is very, not simplified or not simple one. It is a systematic which we have done in the previous lecture series. We have volume of solids of revolution we have calculated. Surface of solid of revolution we have calculated. So these two formulae are just applied here. Some questions which students asked me because they were left in the previous lecture series. So I have taken here these from 6 to 13 questions. They are based on volume and surface areas. Volume and surface area of revolutions. Some questions are of simply surface area we have to find out. Okay, so that I have to calculate here 6 to 13 questions. Okay, and this was a new topic which was double integration, surface area with the help of double integration that we have calculated by projection and that method. Now let me take sixth question. I'm solving with the help of the same formula which we used in the previous lecture series. Okay, we have just discussed them. Okay, in case of polar coordinates, in case of parametric equation, in case of Cartesian equation, all those volume of solid of revolution are discussed about. Please see my lecture series, previous year lecture series. Now let me take further solving this question now. This is twice if I take 0 to pi by 4, because if minus a, we know that since minus a to plus a, if limit is there, this is fx into dx. This will become twice 0 to a into fx dx. No problem. This is definite integral property. So we can write it as similar. This is twice into this means 4 under root 2 upon 3 into pi aq. Okay, now this is 0 to pi by 4 limit. Cos 2 theta can be written as 1 minus 2 sin square theta. This is cos 2 theta here. This formula is in 1 minus 2 sin square theta into cos theta d theta whole power 3 by 2 of this. Okay, now let me rub this. So this can be further solved. Now if I substitute, let me change it. When limits are pi by 4. If I putting here, this is to be solved. So let me putting under root 2 sin theta equal to, let me take sin phi. Okay, differentiating with respect to phi, differentiating it with respect to phi, we get, what do we get here? This is root 2 into cos theta into d theta is equal to cos phi d phi. Simple. Or cos theta d theta is equal to 1 upon root 2 into cos phi into d phi. Let me change the limits also. What the limits here? If I change the limits and put pi by 4, and pi by 4 is root 1 upon root 2. But let me put here at theta is equal to upper limit pi by 4. From this, sin phi will be equal to root 2 upon root 2. That is 1. That means it is sin pi by 2. So phi is equal to pi by 2. And at theta equal to 0. 0 here, theta equal to. This is theta. Theta equal to 0. Phi is also equal to 0. Why? Because sin phi equal to then 0. Sin phi 0 is for 0. Sin 0 is 0. So theta phi equal to 0. So limits are now. Okay, so what do we get? 1 upon root 2. So 1 upon root 2 has again come. 1 upon root, this let me take outside. This is 3 upon root 2. 1 upon root 2 which will come here. I have taken outside. Okay, so that will give us this value. Now limits are 0 to pi by 2. Now new limits are this. Now this is 1 minus sin square phi. This value, because under root 2 we have taken under 2 sin phi, sin theta equal to sin phi. It is sin square phi whole power 3 by 2. Cos theta d theta is cos phi d phi. 1 upon root 2 I have taken outside. It is 1 upon root 2. 1 upon root 2, 1 upon root 2 cancelled out. It is nothing but 4 pi a cube upon 3. Now this is 0 to pi by 2. Now 1 minus sin square phi is cos square phi. It will be cos square phi means cos cube phi. Cos cube phi, because cos square and power is 3 by 2, 2 to cancel out, cos cube phi into cos phi into d phi. It is nothing but 4 pi a cube upon 3, 0 to pi by 2 into this is cos 4 phi d phi. Now this we can apply now a reduction formula. What is reduction formula for cos here? This will give us by reduction formula, that means right here. Hence by reduction formula we get answer 4 pi a cube upon 3 into this is 4. It will be 3 by 4 into 1 upon 2 into pi by 2. What is the answer? 4 cancelled out. Okay, 3 cancelled out. Now 4 is there. It is nothing but pi square a cube upon 4. Upon 4, this is 4 here. So pi square a cube upon 4 here. Right? That is the value which we have obtained. Twice we have already done, so this is pi 1.4. So it is nothing 1.4 into pi square into a cube. That is the value. Fine, because 3 cancel out, 3 by 4, 4 cancel out, and this is 4 in the denominator. So pi into pi square a cube upon 4. This is the answer here. Question number 6 done. Question 6th, sixth question we have done here. Question number 6 here we have completed. Okay, so question number 6 completed. Now let me talk about question number 7. What the question number 7 says, let me check it. Okay, just search for. Now question number 7, what does it say? Okay, now question number 7, let me rub it cleanly. If I just clean it so that it's not dark. Okay, now let me clean it. After cleaning it, after that I'll solve it. Further questions. Okay, so got next question 7.1. Question number 7. What does it say? Let me check it. Okay. Question number 7 here is of what kind? Okay, now question 7 says find the volume of the oblate and prolate spheroids. What are the oblate and prolate spheroids? Let me just define them first. Okay, spheroids generated by an ellipse. When ellipses revolve about major axis and minor axis. If it is about minor axis, then it is oblate. If it is about major axis, then it is prolate spheroid. Prolate spheroid and oblate spheroid are the spheroids which are obtained, or solids which are obtained by revolving the ellipse, okay, about its minor axis, then it's oblate. If it is about major axis, then it's prolate. Further, it is defined that generated by an ellipse. The major and minor axes are which are about the major axis. Okay, about the major axis and minor axis. So major axis, so this major axis, it is oblate, and the volumes of the oblate and prolate spheroids generated by an ellipse. Okay, generated by an ellipse revolving about the major and minor axes of which are, okay, I'm sorry, this is major axis and minor axes are given. So oblate is as I defined, that when we revolve the spirit or the ellipse about the minor axis, then it is oblate, and about major axis it is prolate spheroids. Okay, so that's the definition basic. Now we are given here that major and minor axes of which are this and this. Major axis is 24 pi whole raised power 1.3, and minor axis, length of minor axis is given to us 2b equal to this 3 pi 1.3. Okay, so what is given? Let me write. Question 7 given. What are the things which are given to us? First is there is an ellipse here. An ellipse. Let me write the standard form of the ellipse. Then I'll compare. An ellipse x square upon a square plus y square upon b square is equal to 1. Here the major axis twice a length of the major axis is given to us as 24 pi, I think 24 pi. 7th question, 24 pi whole power 1.3. Okay, and minor length of the minor axis twice b is 3 pi whole power 1.3. These two things are given to us. This is second point, third point, and this is first equation. Not given, but we have just assumed that the standard equation of the ellipse is this. Then if we compare, we are given here length of the major axis is this. Now question is that what is oblate and what is prolate? Oblate is when we revolve the ellipse about the minor axis, then it is oblate here. And what is the prolate? Prolate when we revolve the ellipse about the major axis, that is prolate spheroid. Okay, so we have find the volumes of the oblate and prolate. That's the point here. So let me solve it. So if I take this is, let me take major axis here. Now we can draw like this, because here we have taken the parabola type like that. Okay, so if we take the ellipse like this, major axis this, length of this major axis we are given. Okay, if let me take this is minus a 0 and this is plus a and 0, this is 0 b and this is 0 and minus b o. Okay, now this is the major axis when ellipse when we revolve about major axis, this is giving the prolate spheroid, and when ellipse is revolve about minor axis, then it is this value. Okay, so if I take it minor axis, because first is oblate, so this is revolve about minor axis, it will be pi x square. Here it is p and this is q, this is m, this is n here. Okay, this is length x. Let me take coordinates x and y, but here x and y. Okay, let me take the let me take the parametric equations of this. The coordinates of this are, let me take x equal to a into cos phi, this is a cos phi, and y equal to b sin phi. Okay, so these are the parametric forms, the parametric coordinates, or coordinates which are lying on the parabola here. Okay, so y equal to b sin phi and x equal to a cos phi. This is, we will substitute them later, but first I have to define that what is the oblate here. So volume of the oblate, let me find the solution here. Volume of the oblate. Now here we will take this limits from 0 to this is here. If I take, let me take x coordinate here, so it is 0 to pi by 2 here. If this arc, let me take a, this is b point here. Arc AB is revolved about minor axis here. Okay, this arc if is revolved, then this is 0 to pi by 2. If I take twice of this, that we will define here. So limits are from either this one to this. If I take x limits, then it is 0 to a, limit of x here, 0 to a. Let me take limits of x here. After that, I'll substitute the limits. Okay, so volume of the oblate. Oblate means the spheroid obtained by revolving the ellipse, arc of the ellipse about minor axis. That is the oblate here. It will give us limits here 0 to x coordinate I'm taking, x equal to 0 to a here. This is 0 to a. Okay. So because this we have to revolve about, this arc we have to revolve about 0 to a here. Okay, so and then that is going to give us, if I revolve this about x-axis, and even we can take here 0 to b on 0 to a only. Okay, so this is 0 to a limits, and pi into x square into d x square into d by. This is the point here. Okay, so x square into d by. Why? Because this x square into d by is this height. This is d by. Let me take, because x and y coordinate and d by is this length. Or sorry, we can take ds here. Pi x square into ds. I'm sorry. Length of the arc we take as ds. Okay, because this is length ds here on the arc here. Then we have to substitute what is value of x square, what is value of ds. Now here ds upon dx we have to find out. Okay, so that value we will substitute here. Dx upon dy we have to just calculate. Okay, so this is what we have. Question number 7 we are doing. Okay, question number 7 here we are doing. Okay, that is into d by. This is, I'm sorry, this is d by, because d by we are taking not, this is not the surface area, so this is here d by only. So value of d by we have to calculate from there, this equation with respect to by we have to differentiate it, d by we will calculate, and then x square. Now if I substitute the value of x and y in Cartesian form or in parametric form here, like this x and dy, that will give us then dy upon dx, okay, or dy upon d phi here. That we have to calculate. So x equal to 0 to a, the limits are here. Now this is the formula which we have to apply. What is x square? X square we will calculate from that equation. Okay, so x square we can substitute, and or x we can substitute in case of this polar coordinates or this parameter, sorry, coordinates. That will give us then value. So dy we can calculate from here, dy upon d phi. So let me convert them into d phi. When x equal to a here, then cos phi equal to 0. So limits will be the negative value. When x equal to 0, that means this is 0 pi by, this is pi by 2 here. Negative sign can be interchanged. 0 to pi by 2. To convert them into polar coordinates, then it will give us this value. Okay, so that is the point here. If I just change them into 0 to pi by 2, negative sign can be changed here. Okay, so that let me talk about. Now here x equal to a cos phi. This is, but x equal to 0 to, let me take 0 to pi by 2. I have changed the, or this is pi by 2 to 0. Whenever negative sign will be there. Okay, so by dy is, if I change negative sign, because their negative sign is coming, dy is dy upon d phi. This is, we can write here dy upon d phi, because this is with respect to phi here, and this is d phi. Okay, limits for phi we have to substitute. If I just substitute value of x equal to a, then it is 0, because 1 cos phi 1 is for 0 here. So limits will be minus sign. Let's write here minus sign. I've reversed the limits. So limits are 0 to, sorry, pi by 2 to 0. in this case. So this is pi into x square. X square is a square into cos square phi. Dy d phi from this equation is b into cos phi into d phi. Okay, so these values are given. Now let me write it as pi into a square into b. I've taken outside. Okay, I'm taking positive sign here on. Negative sign I've just neglected here. And even if it comes as positive or negative, doesn't matter, because value must be positive only. Okay, numerical value must be positive. So 0 to is pi by 2, pi into a square into b I have taken outside. This is now cos q phi into d phi by cos q. This is x square. X square is a square cos phi, cos square phi, and d by upon d phi is b into cos phi d phi. This one. Okay. Now we have converted this into parametric form. This is the value finally. So this will give us what the final answer of this. This is pi a square b into cos 3 phi. So reduction formula. Let me apply. So reduction formula is 2 by 3 only. Here it will be 2 by 3. This is 2 by 3 here into 2 by 3 by reduction formula. By reduction formula for cos here, this is cos q phi d phi. Because cos phi and this is square, so cos q phi d phi 2 by 3 only. So this will give us by reduction formula. This we have taken by reduction formula. So this will give us 2 by 3 pi into a square into b. Now we have to substitute value of a square and b from these equations. What is a divided by 2 here? So if I find a, let me substitute that a here. This is a square. Okay, so 2 by 3. This is 2 by 3 by 2 by 3 because 3 if it is there. N minus 1 upon n minus 2 in the denominator. Sorry, n minus 1 upon n only first, then n minus 3. First is n minus 1 upon n, then n minus 3 upon n minus 2, and so on. But it is only 3. So n minus 1 is 2, 2 by 3. This is the only value. Okay, so this is the answer, but we have to convert this into these values. So let me further write it as 2 by 3 pi out and a square. If I have to find out a square from here, what is a square?